so in this lesson we are going to talk about solving absolute value inequality. So at this point you've already solved absolute value equations, and we're just going to throw in some inequality symbols. So first off, you need to know that the absolute value of an expression has to be greater than or equal to 0. The reason for that is, let's say that I have the absolute value of something, and I'm telling you it has to be greater than or equal to 0. That's because this number in here, no matter what it is, let's say that it's -7. The absolute value of that is going to be 7. Or the absolute value of +7 is 7. The absolute value of a number just tells you its distance from 0. So every single absolute value has to be greater than or equal to 0. So you have to keep that at the forefront of your mind. So I gave some steps for solving here. So first, if necessary, you're going to isolate the absolute value. That just means get that part by itself. And then, secondly, you're going to set up two problems. All right, so those two problems look like this. One of them will be exactly what it looks like. The other problem is going to be the same thing that's on the left side, but you're going to switch the inequality symbol and then take the negative value of what's on the right side. Then you will solve for the variable, and then you will graph. All right, so that's kind of what this is showing you down here. So if I have this equation, it's telling you that C has to be greater than or greater than 0, okay? Then you would solve your compound inequality. Now notice that when it is flipped this direction, that is an AND. All right? When it is flipped the other direction, that is an OR. All right? So I would keep this left side the same, and I would flip the symbol, and I would change the sign over here to a -C. The other one is the same thing that's on the left, and then the same part right here. All right? Same thing for this one. One of them is going to be exactly the same, and then one of them is going to be a flipped and an opposite of this sign over here. Okay? So number 1. I see that I have x plus 7 is less than or equal to 2. So remember, when the sign is flipped this way, I know that I'm going to have an AND statement. So I have to set up two inequalities. The first one is going to be what is inside of the absolute value. Same symbol, same thing on the right. So you literally are just dropping off these absolute value bars. That's an AND statement. The other one is what you have on the left side, exactly the same. You're going to flip your symbol around and change the sign of this number right here to -2. Then you're going to solve. So I subtract the 7. X is less than or equal to -5. And same thing over here. Subtract the 7. X is greater than or equal to -9. So this is an AND statement. I need to go all the way from -5 to -9. So let's just start this. You can number these however you want to. I'm just going to say that this is -5. So that'd be -6, -7, -8, and this would be -9. So if I look at this statement right here, it says all of the values I'm going to shade are less than or equal to -5. So on -5, I'm going to have a closed-in circle because I have the equal to. And then I will be shading everything that is less than that. So let's say that I shaded this direction right here. Okay? Then I also have to graph this part. So the values that I'm shading have to be greater than or equal to -9. So -9 is where I'm going to put my dot. There's an equal to bar, so I have to shade in. And I'm shading everything, all of the numbers that are greater than that, so everything to the right. Now this is an AND statement. That means that I'm looking for the values where both of those statements are true. So wherever they overlap. So my number has to be less than -5, but it also has to be bigger than -9. That would be this part. So technically the only thing I'm going to shade on this problem will be the middle part. So from here to here. All right? So number 2. I see that my absolute value is already by itself, meaning there's nothing on the outside of it on the same side. All right, but I notice that this says that the absolute value is less than 0. But I stated on the first page that your absolute value has to be greater than 0. So therefore, this would have no solution. And when there's no solution, you don't shade any part of the graph. Vice versa, if you get an equation or an answer that is infinitely many solutions, then you would make sure that you shade your entire graph. So remember, this has to be greater than 0. All right, so number 3, I notice that my absolute value is by itself. There's nothing on the outside of the absolute value bars on this side of the equation. So I'm going to go ahead and set up my 2 problems. That gives me the same thing that I have on the left, the less than or equal to 2. So exactly how this reads. And since this is a less than, I'm going to go ahead and put my and. Then I'm going to have the same thing that's on the left. And I'm going to flip the symbol and change the sign to a negative 2. All right, now I solve. So I subtract the 3. So x is less than or equal to negative 1. And I'm going to go ahead and subtract the 3 over here. So x is greater than or equal to negative 5. This is an and, so my numbers that I shade have to be less than or equal to negative 1, but they also have to be greater than or equal to negative 5. So I should be shading in between these 2 things. So we'll say this is negative 1, negative 2, negative 3, negative 4, negative 5. So on the negative 1, I have a closed circle. And I would be shading all the values that are smaller than that, so that would be here. But I also have to think about where I'm at with the negative 5, which is also a shaded in circle. And I will be shading in between those 2 because it has to be less than the negative 1, but greater than negative 5. So these are all the values that are smaller than negative 1, but also bigger than negative 5. All right, so on number 4, again, I see that my absolute value is by itself, so I set up my 2 problems. 3c minus 5 is less than negative 2. Notice, since it's less than, we have another and statement. And the other problem, 3c minus 5 is greater than positive 2. But if you look at this, and we should have noticed this from the beginning, this is not greater than 0. Negative 2 is already less than. So if I'm saying that my absolute value has to be something that's less than negative 2, I'm never going to get that negative number. So this one would be a no solution. All right, so I look at this one. I see that my absolute value is greater than or equal to negative 2. All right, so I want you to think about this for a second. There's really no reason for me to even set up a problem here because this is saying when is your absolute value going to be bigger than negative 2? Well, if you think about that, that's all the time. It doesn't matter what I plug in here. It's always going to be bigger than this number because this number is a negative. So when your absolute value is greater than 0 or a negative, that's going to be all real numbers. And I'm going to shade my entire number line. All right, so take a look at number 6. When is your absolute value going to be less than negative 1? Well, absolute values always come out to be positive. So when is that going to be less than negative 1? Never. So this is a no solution. All right, number 7. Okay, so I see that my absolute value is not isolated. I've got a 4 that's being multiplied here, and also have a positive 1. Okay. Also notice this is greater than, so that means that we're right now we have an or. So we'll see what we get when we get our absolute value isolated. All right, so I'm going to pull this down here so I can work with it. So we just want to get the absolute value part by itself. So I notice that I'm multiplying by 4 and I'm adding 1, so I will do reverse order of operations and subtract the 1 first. So now I'm left with 4 times the absolute value of 2x minus 5 is greater than 20, and then I will divide by the 4. So I have the absolute value of 2x minus 5 is greater than 5. So since this is greater than, we do have an or. So I'm going to set up my two problems. Always check that right here once you have your absolute value solved for. You don't want to do it at the top necessarily. So I have a 2x minus 5 is greater than 5. So same exact thing I kind of have here. Or keep that left side, 2x minus 5 is less than negative 5. All right? So I solve for x. I'm going to add the 5. That leaves me with 2x is greater than 10. Divide by the 2. So I have x is greater than 5, or, and then same process here. Add your 5. So 2x is less than 0. Divide by 2. So x is less than 0. So I have x is greater than 5, or x can be less than 0. So usually or statements are going opposite directions. Not always, but sometimes. So we'll just say that this is 0. Well, we better move that over. So let's put the 0 here. 1, 2, 3, 4, 5. So 5, x is greater than 5, so I have an open circle, and I will shade to the right. Or x is less than 0, so open circle, shade to the left. All right, so I need to get the n plus 2 over here by itself, so let's add this 3. So now I have the absolute value of n plus 2 is greater than or equal to negative 3. So at this point, I see that over here there's a negative number. So if this was a less than or equal to, it would be no solution. But this is asking when is an absolute value greater than or equal to negative 3. So when is a positive number bigger than a negative number? And that would be all the time. So I will shade my entire graph to represent all real numbers. All right, number 9. We need to get rid of the negative 7 and the 3. So I'm going to go ahead and add the 7. So I have 3 times the absolute value of d plus 1 is greater than or equal to 6. Divide by 3. So I have the absolute value of d plus 1 is greater than or equal to 2. Since I have a greater than or equal to, this would be an or. So I'm going to set up my two problems. D plus 1 is greater than or equal to 2, or D plus 1 is less than or equal to 2. So if I subtract 1, D is greater than or equal to 1, or, oh, I forgot my negative over here. D is less than or equal to negative 3. So I've got 1 here, 0, negative 1, negative 2, negative 3. So D is greater than or equal to 1. So close circle on 1, shade to the right. Or D is less than or equal to negative 3. Open circle, shade to the left. And I do want to talk about this for just 1 second because it's important to know it doesn't matter what number is in here. It always comes out to be positive. So that's why we change these around, because if there is a 2 in here after we do, take this, so in other words, 1 plus 1 is 2, or anything that's greater or equal to that. So 2 plus 1 is 3, 3 plus, doesn't matter what that number is, it's going to come out to be a number that's greater than or equal to 1, or greater than or equal to 2 if we're thinking about this. We also need to think about anything that will come out to be like a negative 2, because if this is negative 2 and I take the absolute value of that, I get a positive 2. All right, so that's why we flip that around and do the positive and the negative. So on number 10, we're going to add 8 to get that absolute value by itself. And we have 6t minus 7 greater than or equal to 11. So now that we've isolated this right here, I'm going to go ahead and make my two problems. And since this is greater than or equal to, that would be an or. So 6t minus 7 is greater than or equal to 11. Or 6t minus 7 is less than or equal to negative 11. So I add the 7. That would give me 6t is greater than or equal to 18. And then divide by 6. So t is greater than or equal to 3. Or, same thing here, add your 7. And you have 6t is less than or equal to negative 4. Divide by 6. So t is less than or equal to negative 2/3. All right, so I'm going to go up here and plot my points. We'll just say that this is 3. So that'd be 2, 1, 0, negative 1, negative 2. Now, this is not an integer, so we have to think about where that would be on the number line. So it's not quite all the way to 1. So 1 would be negative 3 over 3. So we're just 2/3 of the way to 1. So if you thought about taking and splitting this into 3 sections, I would be 2/3 of the way here. So this would be a closed circle right there at negative 2/3. And I'm going to be shading to the left because that's what is less than or equal to. Or I am greater than or equal to 3. So we will shade to the right. All right, so number 11, we need to go ahead and divide by this 3 here. So we've got the absolute value of 14 minus m is greater than 6. All right. Now that that's isolated, I see that I have an or statement. So that gives me 14 minus m is greater than 6, or 14 minus m is less than negative 6. I'm going to go ahead and solve for m, so I subtract the 14, and that gives me negative m is greater than 6 minus 14, which is negative 8. But I need to get that negative away from the m, so I divide by negative 1. And don't forget that when you divide or multiply by a negative, you have to flip your symbol around. So this would be m is less than 8. Or, same thing over here, subtract your 14. So we have a negative m is less than negative 20. Divide by the negative 1, and m is greater than 20. So we have an or statement, and we're not going to be able to fit all of these on here. So we'll say this is 8, and we'll count by 2s. 6, 4, 2, 0, 2, 4, 6, 8, 10, 12, 14. All right, we're just going to pretend like 20 is out here. All right, so we're greater than 8. So open circle, shade to the right, or less than 8, I'm sorry. We are less than 8, so we will be shading to, well, y'all, I can't count. Let me renumber these. Let's say this is 20, and we'll just say that this is 8. Okay, I'm not too worried about that. All right, so here we have less than 8 or greater than 20. All right, so for the last one, you need to divide by this -4, which is going to flip that symbol around. So we have the absolute value of 6b minus 8 is greater than or equal to -3. Okay, so I see that negative over there. When is a positive number bigger than a negative number? That would be never.